Hey Dad, have you seen my phone?
Yes.
Where is it?
How would I know?
What do you mean, how would I know? You just said you saw it.
I saw it when I bought it for you. You should take better care of it.
Ah!
Ladies and gentlemen, the mean value theorem.
Hello and welcome to the channel. Today we're going to talk about the mean value theorem and why it's just like the punniest dad you know. This kind of dad that when you ask if he wants chocolate or vanilla ice cream, he shamelessly says yes. The kind of dad that sympathizes with a calendar because his days are numbered. The kind of dad that cries at every wedding. Hey, even the cake was in tears. But this is also the kind of dad that cheers you up when life seems hopeless and encourages you to keep on trying. Yes, this is exactly how the mean value theorem operates. Let's see what it says. Mean value theorem. Let f of x be continuous on the closed interval from a to b, and differentiable on the open interval from a to b. Then there exists a value c in the open interval from a to b, such that f prime of c equals the fraction f of b minus f of a over b minus a. Of course, here a and b are real numbers with a less than b. The fraction on the right-hand side is the slope of the line through the xy coordinates a f of a and b f of b. This signifies the average rate of change the function f of x takes on its journey from a to b. Hence, the mean value. The f prime of c on the left-hand side is the slope of the tangent line to f of x over the point c. So in essence, the theorem is stating that there is at least one representative f prime of c of the mean value slope given by f of x on a to b. But how is this like a dad? Well, you are a calc student, c is your phone, and the theorem is your dad. When you ask your dad if he's seen your phone, he simply responds, yes. Here, he is telling you that c does in fact exist. When you ask him where it is, he responds, how should I know? Indeed, the theorem cannot tell you the location of c, it only assures you that it exists. But there is a ray of light in all of this. Since your dad acknowledged that your phone does exist, this gives you hope that you will be able to find it soon. Contrast this to the time you asked him if he's seen your sunglasses, to which he responded only by asking if you've seen his dad glasses. Fanning the flames a little brighter, he grows your hope by encouraging you to look for your phone, but only after you've been looking for it for about an hour. And so, with a little effort on your part, the phone is found, and yes, this means that you can in fact find the elusive value c which your dad, the theorem, told you about. Let's see an example. F of x equals x squared plus 24/7 10 out of 10 on the closed interval minus 1 to 2. This has derivative f prime of x equals 2x on the open interval from minus 1 to 2. Actually, f of x and f prime of x are valid on the entire real line. Anyway, the mean value theorem states that there exists a value c between minus 1 and 2 for which f prime of c equals the fraction f of 2 minus f of negative 1 over 2 minus negative 1. But how do we find c? Since the theorem encouraged us that the value c exists, we can pretend that we already have it and see how it behaves. Perhaps the clearest path to finding c starts at the equality granted by the mean value theorem and then working outwards on both sides. Doing this yields 2c equals f prime of c, which equals that fraction from the theorem, and this equals 251 minus 248 over 3, which simplifies to 3 over 3, and that is 1, at which point we deduce that c equals 1/2. And that's it for today. Math, just like anything else in life, gets easier the more you see it. Take for example your favorite movie. I bet you could watch it for the 247th time and still find some new Easter egg in it. So now that you've seen this video n times, see if you can fill in any gaps by watching it n+1 times. And if you have any questions, be sure to leave a comment down below. If you found this video helpful or interesting, be sure to give it a like, as it helps support this channel. New videos are posted every Tuesday at 2. To never miss out, be sure to subscribe and hit the notification bell. Thank you so much for checking out this week's video. See you Tuesday!